Yes, also internally at ChemAxon, we have a couple of Marvin.js users. That's actually in continuation of what David was mentioning in his presentation before. Yes, we built toolkits, and then we stack them together in order to build a big product or solution out of it. And actually, what I'm showing you now is kind of an example of how such stacking occurs. We have a product that I'd like to talk about where Marvin.js is one of the core components for chemical structure representation and structure drawing, but actually it's used for something else. BioEddy is our web-based sketcher for biological molecules. And biological molecules come in those flavors that you have sequence-derived molecules that have decorations sitting on them, chemical modifications, internal cyclizations and bridges and kind of like. And sometimes people are saying that, well, we use ChemDraw in order to draw those, depict those, but it's not really convenient. That's the reason why we've picked up also with the Pistoia Alliance, and we're since its inception with the Helm project. And we've developed this little web sketcher in order to be able to draw and define such macromolecular entities. You can see on the bottom panel of this slides that we're using building blocks that we're stitching together in order to represent visually what is a larger molecule, a larger molecular entity. But there's always chemical structure behind where possible. There are other elements that are, however, not related to chemical structure. I've introduced this tool before, so it's not probably for many of you the first time that you hear about it, but what I'd like to emphasize today is our kind of the new things that we're working on these days. Because we have a number of deployments of BioEddy in production now, so we had a kind of past year of user experience improvements, I would say. That is, how do people interact with the tools? What are the kind of feedbacks that they need to get in order to be more productive and quicker to kind of define the things that they want to draw? One of those is a kind of highlight feature. Tell me everything that I can actually drop a bond to if it's not already occupied. We added a feature that is particularly useful when you start dealing with larger biologics, say proteins, antibodies, to be able to define sequence domains on the larger sequences that can receive their own set of annotations, for example. This is my favorite, really. We've started off with essentially an infinite canvas where, like in Google Maps, you can just drag around your molecule. But it turns out what users really love and get used to is a scroll bar. Hell yeah, so we've put a scroll bar in our application. What else have we got? There are some things that we've noticed when people kind of start interacting with the monomer library that's often sitting on the right-hand side of the canvas. I'd like to kind of bring this in real quick and kind of have it attached to my sequence. So we've now built in a kind of append, prepend, insert capabilities that lets you directly drop things in place where they are without having to draw extra connections and things like that. And last but not least, that's something that's very important, especially if you look into the aspect of smaller biological entities, peptides, nucleic acids, the ability to seamlessly swap back and forth to chemical structure. That's something that we've also recently put in here. And you'll hear more about this a little later once more, because it's not the end of it. One of the kind of key things that's kind of part of the next half year's plan is the ability to actually say selectively, what are the parts of my structure that I'm interested in on a chemical detail level? And what are the things that are so standard that I don't really care about? The ability to expand individual things and yet have a clean representation of my molecule, that's something that will happen within the next couple of weeks, actually. The next thing is a little bit out of place because it doesn't really so much relate to Marvin.js yet. It's the kind of add-on to BioEddy itself where we're saying, hey, when you have the ability to draw and define those molecules, what are you going to do with those? And just as we have in the chemistry world, JChemBase is the main engine for chemical data representation and the database layer and the ability to search on these. We also have a toolkit that we call the Biomolecule Toolkit that provides the same thing for these biological entities. And by nature, it works like JChem-based. Very much the same flavors. You have a Java API, you have a REST Web Service API. It has native built-in Helm support. It's able to let you standardize the representation that you're creating. It has a database access layer that lets you deposit things. You can utilize it as a registration system. This registration system can work with different business logics that let you configure when do things get recognized as duplicates. There is the ability, once all those things end up in the database, to be able to retrieve them based on sequence features, based on chemical structure-based searches, or on the metadata that's very important to capture in the biologics world anyways. The second last point on this list I've already stressed is a built-in capability to actually go seamlessly both ways. This toolkit is essentially bridging the gap between where classical cheminformatics and bioinformatics sit. So what if you have a chemical structure and you'd like to see what's its sequence? We can do that. We can do that even if you have, say, unnatural residues inside. If you have other kind of linkages and bridges and whatever, if it's in your monomer library, we'll recognize it. If it's not in your monomer library, we'll just flag this corresponding fragment so you can decide later on what to do with it. And the rest is recognized in terms of how these different monomers interconnect. And of course, a couple of property calculations that kind of round up the basic instinct every scientist. I need some data about the compounds that sit in my database, right? Also here, there's a couple of new things I'd like to kind of highlight. One of the most interesting things from our perspective, at least, is, well, we've positioned this thing at the interface between biology and chemistry. Turns out that a lot of users are still kind of captured in the classical molecular biology workflows, where a lot of it is plain sequence. I would say this maybe 95%. We're looking for options if we want to capture entities of all flavors in a registration system. Then the ability to also host bioinformatics capabilities is a very important one. And for this, we are starting to experiment with BioJava, simply because it's an open source package which has a very kind of well-established set of bioinformatics capabilities, so we don't need to start from scratch. Plus, it actually is in place, and a number of industry players and also a couple of vendors are utilizing it. So it has a significant level of support built in, and the more applications are built on it, the more robust it's going to get. We've done a few improvements in our multi-Helm conversion, especially when it comes to additional chemical modifications that are sitting on its multi-sequence components, RNA components. We have a change in a kind of platform that might, for most of you, might not be a concern, but we're requiring Java 8 from now on. There is a lot of work going on right now in order to improve the latest flavor of Helm, which is existing now in version 0.3 or something, largely dealing with ambiguities. So we're working actively in order to be able to provide you a platform toolkit that's able to support all of the actual features that Helm 2 is able to describe. And last but not least, we've also started to work on the registration of entities that don't contain structures. So while starting out as a molecule toolkit, essentially for biological assets, when you look at cell lines, you look at viruses and all these kind of type of modalities, the essence is the same. You're having some data that describes what makes this thing unique within its modality class. And since for kind of no structure elements that we're already having as part of the representation of Helm 2, we're describing these things with sets of metadata. It's just stripping everything away but the structure. So it's not really a complicated thing in order to advance to, but it's something that opens the whole stack of being able to capture everything that you use in your workflows in order to create any type of biological modality. What's in the pipeline here? So we're working on kind of fledging out the registration system capabilities. So we're essentially in the progress of transitioning from a toolkit to something that you can grab and deploy as a registration system. Many of you know the compound registration system, and that has all flavors dealing with the non-functional requirements, as it's often called, application security, user management, and project-based access, and all these kind of things. This is stuff that we're going to add into the toolkit in order to make it a bioregistration application. There is a couple of other things that really point towards tracing genealogy of the things. So that's in biologics development workflow, very important to not only say what's my result, but also see the history of how has it been created. That's something that we're working on actively right now. And last but not least, one of the goals, and this might be news to some of you, starting from a few weeks out from now, I will be the new product manager of the compound registration within ChemAxon. In 2019, my vision would be that we actually do work in order to ensure that we have a registration system for any type of modality, bringing these two strains of development together into one single environment and application. Last, I'd like to give you just a brief hint about use cases that we're serving in the industry. One of them largely is a repetition of something that has been shown at our user group meeting last year in San Francisco. That is a presentation held by Josh Bishop at Merck. They are using our tools in order to support their fully automated peptide discovery pipeline. And they said one of the biggest challenges they have is they have people that do design of molecules, chemists, that are looking at a structure that represents a peptide by looking at the chemical representation. They start drawing these things out. And then they're synthesizing this based on a monomer library, where essentially all these little building blocks are housed in a catalog of about a couple of thousand. And then they have their robots that bring these things and put these things together, and the output is a peptide library, and they start measuring activity. Now, if you're doing structure activity analysis, it's actually rather something like sequence activity analysis. You're starting to look at which position of my sequence, what variation has which impact on my activity profile. And that's something that's dealing completely in sequence space. So I need a way to kind of make this transition seamless, and that's exactly done by what I've described before, the BioToolkit and BioReady can actually do for you. You get a visual representation, and you have the interconversion between sequence and molecule space. This one's along a similar topic. So essentially, we have done a deployment at Heptares that was presented at our user group meeting in Budapest just this year. Heptares has had quality issues. It's not so much about the automation of the process itself, it's more about that they weren't actually sure whether the structures they're having are the right ones. And sometimes if they want to kind of resynthesize a batch of something, they wouldn't know whether they synthesized the same thing that they already had in the past. Problem here is that they have been registering their peptides again in chemical structure format, which was manually drawn, again, using ChemDraw. Takes a lot of time. It's very error-prone, especially when you have to take care of stereochemistry. What they've done is they took our BioToolkit. They've kind of split the chemical structure using our fragmentation technique in order to kind of create individual monomers out of their molecule space, and then started iteratively refining how well are these structures that we have distributed around a consistent set of monomers. So they started throwing out monomers that were drawn falsely and started to curate the content that they have. And they've switched over ultimately in the sense that nowadays nobody draws the chemical structure anymore. And if somebody does it, it can be checked against the monomer library. So the user gets immediately notified that he has actually misdrawn something, because the monomer library has taken ultimate control over, well, the quality of the data that your molecules are generated in. This is a drastic reduction of errors in database registration, and this was really core to identify what is my intellectual property that I have collected so far. They've ended up with something like 400 residues and a couple of chemical modifications, a few hundred. And we're planning to kind of roll out also BioReady for visualization, and also helping them to provide library enumeration tools that let them go through the design phase of their peptide discovery pipeline. And with this, I thank you very much for your attention. I'm happy to take any questions you have.